So get all your articles, upload them, and then get whatever text you would have put in, make that a PDF and upload that too. And so what's going to happen is I'm basically going to extend the deadline till the end of this Friday. So just go back there, fix it, and you should get full credit. Like I said, it's probably something with Canvas. I'm sure it's confusing with this dual format thing. Just turn everything in as a PDF and everything should be fine. And like I said, I'm going to extend that deadline to this Friday. Yes? If you got 5 points, you're cool. That means I saw everything. But for the people who got zeros, that's probably means because I didn't see some of that stuff. And if you got partial credit, that means I saw some of the stuff and I didn't find things I needed, like citations or citation format was off or something like that. But if you got 5, ignore this message. If you got 0, do this thing. Yes?
For all the 5 points that you're giving us for each assignment podcast, is that included in that 100 points? Or is this like
Yeah, so this is working towards your 100 points of the semester project. And so yeah, you got 5 points before for, picking a topic in a group, another 5 points of the 100 to do the proposal. And now the next thing here is a 25-point assignment. That's going to be of your 100 points here. And so I'm going to talk about this real quickly. So the previous 2 assignments, you got full credit if you just did what I asked. This is where quality of your assignment will start affecting your how many points you get. And so all of this is exactly what you find in your semester project PDF. You don't have to take a picture of this. It's literally screenshotted what's in the PDF. So all this information you have. And so just go through this. And the point of the summary, which you can read in the PDF summary, the PDF assignment, or the podcast assignment PDF, is you're going to basically make a written version of your podcast. You're eventually going to make your podcast, but this is you putting it in written word. So it's going to kind of feel like writing a lab report, but much more casual. And the idea is you're presenting your topic as if you were kind of blogging. And if you're just writing to the internet about your topic, given you still cite information, right? You still need to make sure that your information heavily draws from primary literature. And I don't know why I said inflation here. I'm going to change that. All information, not inflation. All information is backed by those primary literature sources. But yeah, you're going to get points for, quality of, explaining the societal and scientific importance of what you're talking about, right? If I don't really see that there, or I don't think you explained it well enough, you're not going to get all those 2 points, right? I'm looking for a logical progression. If I think you're jumping around topics, or you have to backtrack a lot to explain yourself, you're not going to get those full 4 points. So on and so forth. Being general audience friendly, right? If you just throw a lot of jargon in there that you don't explain well, you're not going to get you're not going to get all 3 of those points. And so that's basically what it is. It's basically your podcast in written form, and this is an important step. And I give you 3 weeks to do this. I think due in 3 weeks. Double check me on that, but I think I gave you a little bit more time on that. I think it's an important step because if you do this well, you're going to set yourself for success in the actual podcast, right? If you skip out on this, chances are you're not going to do so well on the podcast. And if you look at the rubric for the actual podcast, it is very similar to this. It's very similar to this in just more points. The actual podcast is worth 50 points. So like I said, if you do well on this, and what I'm going to do is I'm going to give you feedback why I think you did do wrong, why you lost points, and if you try to make that parts better, the podcast is going to be even better and get even more points. So this is a situation, if you do well now, or you recuperate after this assignment, you'll do even better on the podcast. Make sense? Any questions about the podcast? No? Alright, cool. So I haven't extended the deadline yet, but I will do that after this class, and then just turn in sometime this week if you have a 0, and you'll get full credit for the proposal. Alright, so let's talk continue our talk about cardiovascular system. So we were talking about mean arterial pressure, right? We had this equation that mean arterial pressure was correlated to cardiac output times the total peripheral resistance. Cardiac output is how much blood the heart is putting out per unit time, usually minutes, and the total peripheral resistance is all the resistance of all the vessels kind of summed together to make, what is total peripheral resistance. And so if you multiply those two together, you get something that correlates with mean arterial pressure. That essentially means that, if either of these go up, mean arterial pressure will also go up. Same thing is true as inverse. If either of these go down, mean arterial pressure will also get down, right? And we're playing with that concept, right? There's various things that affect mean arterial pressure. There's various things that affect total peripheral resistance, and those in turn will affect mean arterial pressure, right? If you change stroke volume, you're going to change cardiac output, which in turn change mean arterial pressure. So what we're going to do here is we're going to look at something called a baroreceptor reflex. And so this is how your body tries to maintain a constant level of mean arterial pressure, right? This is important because, if your blood pressure is too high, vessels start bursting, right? Things start getting destroyed. If your pressure is too low, you're gonna have a hard time having blood perfused to your organs. You're gonna have a hard time overcoming that resistance of all those tubes getting smaller and smaller. And so this is why we have this Goldilocks phenomena, where somewhere in the middle is just right for your blood pressure, and that's what your body tries to do: maintain somewhere in the middle. So here we have our diagram. We have our left ventricle, and then coming out of it is our aorta. And in this example, it splits into two arterioles. So the special thing with what we're adding to this is nothing new, right? Heart pumps into the aorta points into arteries, which will branch out into arterioles. That's nothing new. But the new thing is we are adding these guys to the aorta, and these guys are called baroreceptors. Baroreceptors basically are in charge of detecting pressure. And so in this slide we'll show you how they do that. So in this example, in this scenario, let's say this particular arteriole, we'll say there is some local control occurring here. There's some local control here, and it's going to constrict the arteriole. Because let's say there's some blood loss happening here, maybe we have some hemorrhaging, maybe there's a cut somewhere, and to minimize the loss of blood, arterioles will close up. So we're going to have a decrease in the radius of this particular arteriole. So let's change that drawing here, something like this. Right. So a change in the radius of this arteriole, how is that going to affect that particular arteriole? Skipping ahead. The radius decrease, what's going to happen to the resistance? The resistance is going to increase in that particular arteriole. And so how is that going to affect the total peripheral resistance? If the resistance of that one arteriole increases, then the total peripheral resistance will also increase. Because remember, the total peripheral resistance is the summation of all the resistance in all the vessels here. Right? And so if total peripheral resistance increases as well, what's going to happen to mean arterial pressure? Increase too, right? That's this portion of the equation right there. And so what's going to happen when mean arterial pressure increases, the aorta is going to stretch, right? So it's gonna, this is kind of exaggeration, but it's gonna bulge out. It's gonna stretch out as pressure increases. Aorta and other arteries are gonna kind of stretch out. And so these baroreceptors also will get stretched out. So the baroreceptors stretch, and then that means they activate. When they activate, they send a signal to the cardiovascular control center and the medulla oblongata. And they do that via an afferent neuron. And so I didn't talk about this before, but what exactly is a cardiovascular control center? Well, I said it's in the medulla oblongata, but what literally is it? If you had to point to something, what would you point to? Yeah, you basically point to cell bodies. It's really, a control center is just really a network of neurons. And that network of neurons is pretty complicated. It's this kind of weird circuit. And so a lot of times we either don't understand it or we don't want to explain the whole story to students. We just kind of black box it. We kind of abstract the idea of that network and how it works exactly and just call it a control center. Sometimes we black box it because we don't want to explain the whole story to you students. Sometimes we black box it because we don't really know all the parts to it. And so we just kind of assume it works as a certain unit and just call it a control center. And in this situation, we have a good idea about what the control center looks like for the cardiovascular system, but we don't know everything about it, of course. All right, so